Welcome back to our channel, ladies and gentlemen. Now today we want to start with this simple geometry problem. So you've been given two inscribed quarter circles and the yellow semicircle. Then you've been told to find the radius r of the quarter circle. So if we transfer this problem to the whiteboard, now to find the radius r of the quarter circle, then here we've been given the radius of the semicircle is 5. Meaning from point O to B is also 5, from point AO to A is also 5. Any line from the center to the circumference is the radius. So for us to get the radius of the quarter circle, remember this, the quarter circle, the radius is R. Meaning that will also be R. So if we divide this diagram in this manner, then what will it imply? Any line from the center to the circumference of the semicircle is the radius of the semicircle. So if from O to this point is 5, then again from O to C is also 5. Because it is from the center to the circumference, that is the radius 5, which we've been given to be 5. Now, if the quarter circle has the radius of R, meaning if this is R, then it means this is also R. Then this will also be R. Then from this point to this point is also R. So if you let this point to be X, then you can see from A to X, from point AX, A to X is R plus R. That is 2R. Then from A to O, AO is the radius of the semicircle, and the radius of the semicircle from A to O we've been given to be 5, the radius of the semicircle. So it means AO is 5, and from A to X is 2R. So what about O to X? So for you to get the length from O to X, then it means it is from A to X minus from A to O. So OX is going to be AX, then minus from A to X minus A to O. Then you get that length OX to be 2R minus 5, because AX is 2R and AO is 5. So it means from O to X is 2R minus 5. Now if you look at triangle OXC, that triangle OXC is a right angle triangle. So if it is a right angle triangle, we can use Pythagoras theorem. And when we know the two shorter sides are A and B, then the longer side is the hypotenuse C. So according to Pythagoras theorem, we have C squared is equals to A squared plus B squared. So if you do the substitution, C is 5. So we are going to get 5 squared is equals to A. A is 2R minus 5. That is going to be 2R minus 5 squared. Then it is plus B squared, and our B is R. So it is going to be plus R squared. So if you do the expansion, 5 squared is 25. Then 2R minus 5 squared, that is a quadratic identity when you have A minus B squared. That is normally A squared minus 2AB plus B squared. So if you use that here, what do we get? A squared is going to be 2R squared, which is going to be 4R squared, minus 2AB, that is now going to be 2R times 5 is 10, then times minus 2 is now going to be minus 20R. Then plus B squared, B is 5, so that is going to be plus 25, because 5 squared is 25. Then it was plus R squared. You add that, your R, which was there. Now if you look at this, 25 and 25 will cancel out on either side of the equation. So this side we remain with 0 to be equals to 4R squared, and plus R squared is going to be 5R squared. Then minus 20R. Now if you look at this, R is a common factor. So you have, this implies that you have 0 is equals to, if you factorize out 5R outside, 0 is equals to 5R into, here you will remain with R minus 4 minus 4. What is the radius R? Now here if we have 0 is equals to 5R into R minus 4. So this implies that either 5R is equals to 0, or R minus 4 is equals to 0. So when two factors are equals to 0, then it is either the first factor, which is 0, or the second factor, which is 0. So from this you'll get R is equals to 0, or R minus 4 is equals to 0, you'll get R is equals to 4. Because the radius is there, meaning when r is equals to 0, the diagram does not exist. So our r is equals to 4. Ladies and gentlemen, the radius of the quarter circle is 4 units. That is the simplest method to determine the area of the quarter circle. Thank you for watching and see you again in our next presentation. Don't forget to subscribe.